learning series brought to you by Turtle & Hughes, your authorized Rockwell Automation distributor in New York City metropolitan area, Long Island, and New Jersey. My name is Lorenzo Paganotti, and I'm an automation specialist here at Turtle. In this video, I'll demonstrate the configuration steps in order to use the Kinetix 5100 drive in standalone mode. We'll configure the drive from factory default, set its operation mode, scaling. We'll assign functions for its I/O points, configure a homing sequence. We'll define an index routine, and then use the scope tool to monitor all of that. We'll also demonstrate the operation using a demo that you'll see on the screen shortly, and finally go through how to access supporting documentation for this product. But first of all, we need to download the Kinetix 5100C tool in order to configure this drive. Alright, so on your favorite search engine, you can look for Rockwell product compatibility. And you see the first option here will be the automation portal. And you'll land on this page, compatibility and downloads. You look for the search button and type Kinetix 5100. Once you're presented the options, you'll click on this first guy here. You'll land on this page and hit downloads. You will click on select files. And from here, you'll pick the software which is on the bottom, as in tools. Select the software, hit downloads, and finally download now. Just bear in mind that this drive is configured over USB. So you see the USB cable that's connected to my computer, and the USB COM port will correspond to the physical COM port that is connected on your end. So in my case here, I have on COM port 5, but if I change the USB port, I might land in a different port. Just make sure you have the right one in mind before you launch the software, so you can connect to the proper port. Once you have the software installed and launched, this will be the first screen that will be greeting you here with the project name and the location in which the project files will be stored. I can name this anything. For this case, I'm just going to use K5100 demo -1. Gonna hit OK. Oh, there's another one like that already. So number 2. Now you notice that COM port was already selected automatically. If I had a different one here, I'll be a little concerned, but in this case, we're good to go. So we can hit add and finally add this project. Once you're here on the main page, you see that the parameter editor screen popped up first, but we want to go online with this drive. So I'm going to click on this button and I'm going to choose to download all parameters to this drive. Remember, this is a brand new project that we just created, so there's no configurations whatsoever on this drive. I really want to do a clean install and start from scratch. Let's wait until it's completed. Download parameters into drive successfully. Yes, I want to continue with the download, and this would do a quick reset on the module. You see it's going to turn off and turn it back on. Drive is back online, and now you see on top of the screen that I'm online. The first step after downloading the program to the drive with the blank code is to select the motor operation mode. That's done under the settings tab. So what you do, you're going to click in here and you get to the operation mode tab, and you pick the operation mode in which you're going to use. In our case, we're going to use position mode register input that looks for digital I/O points in the input cards as the reference for triggering, starting and stopping our indexing moves. The PT position mode, even though it says terminal block input, that refers to analogs and pulse input styles, which are not what I'm going to do today. So selecting PR, I can hit download and accept. Next, we need to select our motor for this application. Notice here that when you click on the motor selection screen, you get to this tab where you specify the device. Now, you can pretty much go and pick the catalog number manually over here, if you know it, if you have it, but I believe that the safest thing to do is to use the non-volatile memory from the encoder device to populate that information automatically for you. So all you have to do here is to leave it as motor NV. Hit next. All this information is grayed out because you are going to populate this from the encoder, from the information on the motor. Same for this case, and then click download. Press yes. Wait until the drive reboots. Reset module complete. Now my auto identify is completed as well. So if I go back to my motor tab, you see that a catalog number has been populated, and all my other motor datasheet info and model information is in here. Next, you look at the general setting. This is where you would configure the rotation direction, also known as polarity. You also look for the shunt setting, in which you can choose between using the bus regulation for internal braking or an external braking in case you're using an external brake resistor. In this case, we can also use a brake time setting, which corresponds to the holding brake or an external brake device on your mechanism. You can also enable this for vertical load control, as it would control the engagement of the brake in a timely fashion. In our case here, I don't really care much about this configuration, and I'll move forward to our scaling portion, which is right here under E-gear ratio. The electronic gearing is a very important part of the configuration process, even though if you're not using electronic gearing per se, where you're tied to an external feedback device or a secondary motor in which you want to have electronic gearing with, this page also gives you the scaling for your application. So notice that the first number here on top, gear ratio follower, this represents the effective resolution of your motor feedback device. So in our case, we have a device. If you don't remember, you can go back to the motor selection tab, go on motor feedback, and you see here that the effective resolution is around 16,700,000. Now, this is my effective resolution per revolution. To simplify our example, I'll define our rotation in an angle or a position in degrees, where 360 is our master ratio, which corresponds to 1 revolution. In other words, if I command my motor to move to position 30, the motor will rotate 30 degrees. If I tell the motor to rotate 360, it will complete a full revolution. You can use the same logic to scale the counts based on your application, whether if it's rotary or linear. Just make sure you're factoring in the reduction ratios present on your mechanical arrangement. In my case, my motor is directly coupled to this dial, so my ratio is 1:1, so I can use 360 degrees here. Now that we have our gearing or our scaling properly set up for 360 degrees for a full revolution, we will need to configure the digital I/O points. So you would do that under here, under digital I/O/jog control. So you can see the tables that are representing the digital inputs and digital outputs on the bottom, where you can assign the functionality of each of them. What you have to do first is by default, when you get to the screen the first time, you'll be able to see the status of each of those inputs. So I will just enable the camera so you see what I'm doing. So this is my first digital input. I'll flick this and you see that my status has changed from off to on and back to off. I'll go to the sixth one just to see that my IOs are connected to the drive already. Now, if I need to configure the actual functions of my IO, I'll have to select this and start making the changes to the parts that I want to use. You don't need to see me going through each of those drop-down menus, so I skip that part and you see my selections here. I'm using my first digital input as my servo on and off, which is me enabling my motor. The second one is the command trigger. This has to do with the position mode that we're using. We'll see about that in a little bit under the PR mode editor. The third one is the same. It also has to do with using my register position commands. We'll talk about that in a little bit. Digital input number 4 right here will be my homing switch. Now I don't have a proper limit switch in this case, so I have to simulate a limit switch to come to a stop at my origin. So I will use DI4 for my homing switch and DI5 for my enable homing, which is when I will call a home. And I will also use the DI6 as my stop. Okay. For the outputs, I have servo ready in my first one. I have servo enable in the second one. You see, it's going high. And I have DI3 as my homing sequence completed, and DI4 as an alarm if I run into any trouble. So if you want to start having some level of motion here, just at least we see this motor spinning for the first time after me talking for so long. What we can do is we can use the jog function on the bottom. First we have to enable our drive, so I'll use the digital input 1 for that. So now the drive is enabled, and now I can use the arrows here to move the drive. I hope you're seeing on the screen the drive rotating. I can change the direction, and I can also play with the speed, go a little faster. Boom, there you go. All right, I'll try to stay pretty much at 90 degrees here, so we have a reference for our angles. Okay. Next step is to use the PR mode editor. So this is where you configure both the homing sequence and the indexing moves, or whatever moves you want to perform in a sequence. So open this screen. Let me remove the video just so you see the whole screen. Okay. Now I know this looks a little busy, but bear with me. Let's go under the homing setting first. All right. So under the homing mode is you select the homing function. Now there are a bunch of different ways to home this drive, and you can find more information on the manual. For the sake of demonstration, what I'm going to do here is I'm going to home in the forward direction until we see a transition from off to on of my homing switch. And when that happens, I will define my origin position as 0. You can hit download. Alright, so let's test this homing position method, right? I can enable my drive first. And remember, I have DI5 as my homing sequence, or start homing. I'm calling for the homing sequence here. So I'm going to flick this guy. Now my motor is looking for the homing switch transition from off to on. Once this guy goes high, which is my homing switch, or I'm simulating a limit switch here, remember that. Once this guy goes high, this is going to reverse direction until it sees a transition from high to low. So watch this. When I flick this, this guy's going to reverse direction in the lower speed, and when I flick it back to 0, it will stop. Done. There you go. I want to be pretty much right here at the 90 degrees for my reference. All right, so I'm homed. Now I can start playing with my indexing moves. The indexes and every other move are configured under the PR mode setting. So all you have to do is select one of the PR modes available for you. You have 99 of them. I'll start with the first one and I'll choose the move type that I want to use. From the drop down, I will select 3, which is a point-to-point command that I will proceed to my next command when completed. I want to use an absolute move. I don't need to interrupt anything or overlap anything. I will leave my XL and decel time as my standard. What I'm going to do here is I will add a little delay of about a second between each move. So my first move, I'm going to go to 90 degrees. So if you remember, my motor is set right here. So if I move 9 degrees, I'm going to do a 9-degree angle and I'm going to stop pretty much here, right? I'm going to download this. I'm going to take the screen out of. Okay. My next move will be, I want to go back to 45 degrees. So again, point to point, an absolute move of 45, also a delay of 1 second, pretty much the same as the other one. So I'm going to 9 degrees, then I'm going back 45. Then I think I'm going to go to 180. I'm going to go to 180. Or bad, I can go to 360. Just going to go do a full revolution, right? Same stuff. 1 second of delay between the moves. And once I get to 360, I'm going to go back to the first instance, which is I'm going to jump to a specific command, target jump to PR number 1, which is the first one here. Download. Okay. So just to recap what we're going to simulate now, I can open my I/O configuration just to remind everyone what the I/O configurations are. I promised to talk about this. So DI3 and DI2. DI3 register position command. This is the time where you tell the drive that the drive will be looking for the registers of position commands from 1 to 99. So if you remember the PR mode setting, you have all these PR available for you, and you can choose to use them or use a different register. So in our case, we're going to use the register from 1 to 99. So I have to tell the drive that first. So first thing I need to do here is, let me just enable the screen. I'm going to go and enable DI3. Let me just take this down so you see the status. And command trigger is when you actually calling to start the position commands or your indexing moves. So remember what we're trying to do here is I'm going to go 90 degrees, I'm going to go back 45, then I'm going to go to 360, then I go back to 90, and then 45, and then 360 again, and on and on and on. All right, let's trigger this. 45, back to 360, then back to 90, 45 again, back to 360, and on. That's going to repeat there forever unless I tell it to stop using this guy over here. It's my stop button. And there it is. You have an indexing move performing in relatively a couple of minutes. So you can always observe what's going on with the motor and the profile using the scope as opposed to physically looking at the axis. So you can open the scope meter here. You see that you have a total of 8 channels to monitor simultaneously. I unchecked a couple that I don't want to be looking at. I'm just interested in a couple of things. So I'll look at my feedback position, which is where I'm located, my motor speed, my command position to see how tightly I'm following my feedback position. And I think I'll also look at the index PR of command, in which commands or which index the PR numbers I'm following. So I'm going to run this, and let me rehome the system. All right, I'm rehomed. Now I'm going to trigger the indexes. Now, of course, this thing is all off scale, but let's run this just for a little bit so we can start playing with the scaling. All right, that's enough. You can now click on the green button here where you change the perspective. So you can now observe each channel separately. You can use the mouse to select the specific waveform that you're interested in. So you see here feedback position. When you scroll over, I'm following pretty tightly with my command position. I'm doing well there. My motor speed, even though it looks a little bumpy, this deviation is very small. It's from 50, 51. If I tune this motor, I can probably go a lot tighter and smoother than this. And there it is. This is a demonstration of how you can use the scope, how you can set up a quick index move on this drive. And if you have any questions, you can contact us. My email will be on the contact of this video at the end of this video, and you can also reach out to our team for any questions. In case you need to access documentation or sample codes, or even further description of the drive, you can access the rockwellautomation.com and use the search feature to look for Kinetix 5100. Dial enter. You notice that the search results are shown here in different tabs. As default, you'll be looking at the product information and the catalog numbers, product lifecycle status. You can filter those. You can also click on literature for a formal documentation tab, and that supports this product. So the documentation and publication type can be filtered through these categories here on the left hand side. I'll go ahead and pick the user manual, and over here the user manual link will be available for download. You can click that, and like that you have access to the files that you need. And with that, we conclude this video. If you have further questions, please contact me at the email on the screen or reach out to the automation team at turtle.com. Thank you for your time and have a great day.